In question 28A, a child is going down a snow hill on a sledge. Complete this free body force diagram. Free body force diagram actually represent all the forces which are acting on the object. So when objects are in contact, the surface apply a force we call a normal contact force. Weight of an object is acting downward. And as there will be as a opposite to direction of motion, there will be a friction. So friction try to resist the motion of an object. So vertically upward, this will be a normal contact force or a contact force. This will be the weight of the object, and this one is a friction, or you can also say drag or air resistance. So same diagram you have to complete on this part. This is representing like a single body object. A boy is considered as a single body object. So free body force diagram represent all the forces which are acting on the object. Then the last one is question 30 part A. 30A. A moving walkway transports people horizontally over a short distance. A child stands on a walkway that is moving at a constant speed of 1.9 meter per second. Halfway along the walkway, the child turns around and attempts to walk back towards the start at a steady speed of 1.9. Explain why the child will not reach the start of the walkway. So basically, like this is a walkway, say, and this walkway example is the direction of the movement of the belt of this walkway is towards right, and that is 1.9 meter per second. So a child started from here. When he reached the halfway, he want to return back. So he turned around and he start to walk, but in opposite direction with the same speed. So as the movement of the walkway is towards the right and the child example try to move towards left, so he will never, or as you can see, he turned around. Why the child will not reach the start of the walkway? So why he will not reach the start of the walkway? Because there is no resultant velocity. As the walkway is moving towards right and the child is moving towards left with the same speed. So if it is plus 1.95 meter per second for the walkway and minus 1.9 meter per second for the speed or velocity of the child. So what is the result of these two velocities? The resultant velocity is 0. So if the resultant velocity is 0, that's why the child will not cover any displacement or he will not return. So it will appear that the child is stationary or he will remain at its position. So the resultant velocity of the child is 0. Why? Because the direction in which the walkway is moving is opposite to a direction in which the child tried to walk. So as the two velocities are in opposite direction, the resultant will be 0. Like because he's in contact with the walkway. So the backward velocity and the forward velocities are same. So resultant velocity is 0. That is what happened. Like example, if you're using a treadmill, you remain on the treadmill if you're running with the same speed as the belt is or a conveyor belt is rotating. So you'll remain at the same. You will remain at one position. Why? Because the movement of the conveyor belt and your velocity both are in opposite direction. So resultant will be 0. So when the resultant velocity is 0, your displacement will be 0, or you will remain at your original position, or it appears that you're stationary.